Good morning. Welcome to this video lecture on capacitance. Can you guess what is common in all these pictures? Yes, if you take up the first application, that is a camera flash where the electrical energy, impulse electrical energy, is getting converted into a light energy. And if you take up the fan, you need a device for the continuous rotation of the blades. And what is the principle behind a proximity sensor? And can you guess how the uh, data, right, ones and zeros are going to be stored in the DRAM? Yes, all these like applications needs a device called as capacitor. Let's see what is capacitor. Capacitor is a device which can store energy in the form of electric field. If you take up the arrangement in the capacitor, it has got two parallel plates separated by a distance d. And this separation, right, this gap is going to be filled with a dielectric medium. And the property of the device, we call it as capacitance. Capacitance is the ability of the device to store charges per volt. And if we need to calculate the value of capacitance, then we need to follow certain steps. We will just see what are the steps involved in the calculation. First, we need to identify the direction of electric field using symmetry. That is, we need to identify what is the Gaussian surface that is involved. We have to calculate, after identifying the Gaussian surface, we have to calculate the electric field everywhere in that particular surface. And third step, we have to compute the electric field potential or potential difference. In simple term, we can call it as potential difference. Once the potential difference is known, we can easily calculate the value of capacitance. Let's take up a parallel plate capacitor. Right, first we need to identify the direction of electric field. So we need to know the Gaussian surface. So in a parallel plate capacitor, the charges are going to be stored on the surface of the plates or the electrodes, right? So that electrode's surface is going to be the Gaussian surface. And if we calculate the electric field automatically, right, we need to apply the rule. Gaussian law we need to apply. That is closed integral of the electric field over the surface area. That is going to give you the value of electric field. So closed integral of E dot E. E is the electric field intensity, right, into your dot in the area that is going to give us the electric field everywhere. And if you take up that one, it is going to be Q by A epsilon. So what is Q by A? That is the charge density that is going to be present, right? So charge density sigma divided by epsilon is going to be the electric field that is going to be present on the Gaussian surface. Then we need to calculate the potential difference. If you calculate the potential difference, again, the difference between the potential across plate 1 and plate 2 has to be calculated. Okay, right? So that will give you the potential difference, and here it is going to be depending on the distance of separation d, the area of the plates, and the dielectric medium, nature of dielectric medium that you consider. And the fourth step, when you calculate the capacitance, it is going to be Q divided by del V, right? So automatically it will depend, the value of capacitance will depend upon the area of the plates, the nature of the dielectric medium, and the distance between the separation, between the electrodes. Right, so parallel plate capacitor, when you consider a parallel plate capacitor, it can be equivalent to a system in Cartesian coordinate form. Suppose if you consider a cylindrical a system in cylindrical coordinate form, then automatically we have to consider a coaxial cable. In that case, the structure of a coaxial cable is analogous to a cylinder, right? So in that case also, we have first step, we have to analyze the Gaussian surface. The surface we have to consider. So let's take up a cable with inner diameter A, with inner radius A, and outer radius B. Okay, and this whole surface is going to be the Gaussian surface. And if you apply the Gauss law, second step, if you apply the Gauss law to calculate the electric field, automatically the charge density divided by 2 pi r epsilon will give you the electric field that is going to be present everywhere. So r is going to be the radius. Suppose if you can consider the radius in between A and B, or in A also we can consider, or in the B surface also we can consider. So R is the arbitrary position that you consider for the analysis. Third step, we can calculate the potential difference. So automatically the potential difference is between the inner core and the outer core. Automatically you can consider your limit between A to B, and you get your get the potential difference as rho L divided by 2 pi epsilon ln of B by A, and from that you can calculate the capacitance easily. If you take up the next one, right, suppose if you take up a spherical coordinate system, a concentric sphere will be the best example for a spherical coordinate system. In that case, we can consider a concentric sphere, right? So this is going to be analogous to what we learnt before. Here again, this surface is going to be the Gaussian surface. The inner surface is going to be the Gaussian surface. So your field is going to exist everywhere in the Gaussian surface. And if you take up the electric field, right, unlike your previous one, here we are going to have only charge density divided by 4 pi epsilon r square. So it depends upon the radius also. And we can find out between the charge, if you find out the potential difference between the inner core and the outer core, we can find out the limit. We can take it as a limit to find out the potential difference, and thereby we can calculate the capacitance easily. Okay, moving on to the electrical aspect, right? A capacitance exists in a transmission line also. So between two cables, there exists a capacitance, right? So one cable will act as one plate of the capacitor, the other cable will act as the other plate of the capacitor, and the dielectric medium is going to be the air, right? So across the transmission line also, capacitance exists. So in that case, if you consider the transmission line, right, the Gaussian surface is going to be the cables, right? So the two cables that are going to be present, that is going to be the Gaussian surface. And we can calculate the electric field in the Gaussian surface. So automatically, right, so we'll be considering the line charge density of both the cables, and we can find out the potential difference across the cable, and easily we can calculate the capacitance. Hope you would have understood the concept of capacitance and how we can consider it for various medium, right? And I'm sure you'll be able to take up this assessment too. Thank you.